Welcome to this channel. In this particular tutorial, we will design and simulate the sense amplifier circuit using the LTspice tool with the help of PSIM models. For more such videos, I request you to like, share and subscribe to my channel below. Open the LTspice tool and then click on Component. From the Select Component symbol, we must select the P-channel MOSFET transistor and click OK. In order to mirror the transistor, we use Ctrl+E and similarly place another transistor as shown in this particular tutorial, and in order to mirror use Ctrl+E. Now click Escape. Now click on Components and from Select Component symbol, select N-channel MOSFET transistor and click OK. To mirror the transistor, use Ctrl+E. Now place the transistor number M5 as shown in this particular tutorial and click Escape. Now let us zoom back and then we have to place the other components. So click on Component and select a P-channel MOSFET transistor and click OK. Now in order to rotate the transistor, use Ctrl+R and we have to similarly place the other transistors also. So place this particular PMOS transistor and click Escape. Now again click on Component and from this select the PMOS transistor. In order to rotate, use Ctrl+R and click Escape. Click on Components and select the voltage source. Now place this particular voltage source on the schematic window. In this design, we require 4 voltage source. So we will place 4 voltage source as shown in this particular tutorial. Right click on the first voltage source, change the DC value to 1 volt and rename this voltage source from V1 to VDD and click OK. Now click on wire and extend the wire across the voltage source VDD and then place the ground at the negative terminal of the voltage source. Next, click on Label Net and name the label as VDD. Right click on the second voltage source and let the value of DC source be 500 millivolt and click OK. Now right click on this particular voltage source and change the name as VNM. Click on wire and extend the wire across the positive terminal and then place the ground. Next, click on label net and name this label net as INM or VINM. Right click on the third voltage source and rename this as VINP and click OK. Now click on wire and extend the wire across the positive terminal and then place the ground connection. Next click on label net and name this label net as INP and click OK. Now right click on the voltage source and click on advanced and select the pulse. Define the V initial as 0.4, T delay as 5 nano and V on 0.6, T rise as 10 picosecond, T fall as 10 picosecond and T on as 4 nanosecond and T period 12 nanosecond and then click OK. Right click on the voltage source V4 and then rename this to V clock. Now extend the particular wire across the positive terminal. So click on wire and extend the wire across the V clock and click on ground and place this ground terminal across the negative end. Now place the label net called as clock across the extended wire and click escape. Right click on clock and click on advanced. Select the pulse, define V initial as 0, V on as 1, T delay as 0 seconds, T rise as 10 picoseconds, T fall as 10 picoseconds, T on as 5 nanoseconds and T period as 10 nanosecond and click OK. Now click on wire and connect the source of M1 PMOS to the drain of M3 NMOS and the M2 PMOS to M4 NMOS. Now the gate of M1 PMOS is connected between the M2 and M4 transistor and the gate of M2 PMOS is connected between M1 and M4 transistor. Connect the M3 NMOS to M4 NMOS as shown in this tutorial and the gate of M3 NMOS is connected between M2 and M4 and the gate of M4 is connected to M1 and M3. Now, the drain of M5 NMOS transistor is connected to M3 and M4 gate and connect the M6 PMOS transistor to the gate of M5 NMOS transistor. Now, the drain of M7 PMOS transistor is connected between the M2 and M5 transistor as shown in this particular tutorial. Click on wire and extend the wire across the M1 PMOS transistor and also extend the wire across the M2 PMOS transistor. Now click on label net and place the label net VDD on the wire as shown in this particular tutorial. Now place the VDD also across the explicit substrate of all the PMOS transistor. Click on wire and drag the wire across the M6 PMOS transistor. Similarly, drag the wire across the M7 PMOS transistor. Now click on label net and then type INP and place on the M6 transistor. Again click on label net and type INM and place this across the M7 transistor as shown in this particular tutorial. Now click on wire and connect the M7 transistor to the gate of M5 NMOS transistor and click on ground and place the ground across the M5 NMOS transistor. Next, place the ground across all the NMOS transistor substrate as shown in this particular tutorial. Now right click on the M1 transistor and define the model name as P underscore 50 nano. This model name is as per the PSIM model file. Now define the length as 50 nano and width as 1 micro. Now right click on the M2 transistor and define the model name as P underscore 50 nano and the length as 50 nano and the width as 1 micro. So make the changes accordingly for M7 and M6 transistors. Similarly, right-click on the NMOS transistor and define the model name as N underscore 50 nano. Define the length as 50 nano and the width of the transistor as 500 nano. So, define the same for the M4 transistor. Define the model name as 50 nano, the length as 50 nano and the width as 500 nano. Right click on the M5 transistor, define the model name as 50 underscore N underscore 50 nano, length as 50 nano and the width as 500. Click on label net and define this as clock. Place this across the schematic. Now click on label net and define this as out P, and also similarly we have to define the label net called as out M. So click escape and click on label net, define this as out M, click OK and place this label net accordingly. Now next click on the edit and we have to perform the spice analysis. So click on spice analysis and then select the transient analysis. Now define the stop time as 30 nano and click on skip initial operation print solution and place this on the schematic window. Now, we must define the BSIM model file for this particular simulation, and this is present in a particular folder. So click on File and click on Save As, and save in the folder where we are trying to save this particular sense underscore amp schematic. And the bsim file, the bsim model file must be present in the same folder. Now click on edit, click on spice derivative, and we have to include this particular bsim model file. So write this particular spice derivative and click on OK, and place this particular spice derivative on the schematic window. Run this particular simulation and place the cursor across the clock. Now right click, click on add plot plane and place the cursor across the INP. Now add plot plane and place the cursor across the output P and click on add plot plane and place the cursor across outm. Now you can see the simulated result for this particular sense amplifier. Thank you for watching this tutorial. I hope this has helped your learning purpose. I request you to like, share and subscribe my channel below.